Hello and welcome to Saturday's edition of Cracking the Cryptic, and we've got an interesting puzzle today. No less than 3 people have written to me, despite the fact this only was published yesterday on our Discord server, to say that we need to cover it on the channel. Well, your wish is my command. This is by another new constructor to Cracking the Cryptic. This is by Elias Kar, and it's called 10 Arrows. And I think we can all see why. Anyway, let's. It's an absolutely classic arrow Sudoku, so it's right in line with our forthcoming app. I'm pleased to tell you I've already received some puzzles towards that app, so it is off and running. It's a way away yet, but it's very exciting for us. Before I read you the rules, Groundhog Day Sudoku is available for everybody over on Patreon at the moment. I definitely recommend it. It's got a great penny drop, and we'll keep listing the successful solvers at the end of one of our videos every day with Star Wars style credits, and because we get copyright striked if we use the Star Wars music, we've been using the wonderful music by Kurt Hugo Schneider. If you've not heard it, it is a beautiful tune. It really is. I haven't yet learnt to play it on the guitar because I think it would be quite tricky, but it's one of those pieces of music that makes me want to learn it. So yeah, give it a listen. I recommend it. Now, what are the rules of Elias Kar's puzzle? Let me read them to you. We have got normal Sudoku rules apply. Digits along an arrow must sum to the digit in its circle. Digits may repeat along an arrow. And Mark's put a note here. Right, okay, so Mark put this in the software for me. He says he's made this one purple to make sure it's clear which way round the arrow goes. I see why, because if this arrow was grey, we might have thought it could bend back on itself like that. You wouldn't have quite been sure which direction these arrows went in, whether they did that or whether they continued. So obviously they're meant to continue, which is why we have one purple arrow in the grid for a change. Do have a go at the puzzle. The way to play, of course, is to click the link under the video. I have no idea how difficult this puzzle is. I'm presuming it can't be that bad if so many people have solved it since it was published yesterday, but we shall see. With that, let's get cracking and see how we go. Now, the first place my eyes are taking me is here, because that is a 4-cell arrow, and that means this square, well, what's the minimum I can make those 3 cells? They could add up to 6 if I make those digits 1, 2 and 3. 6 plus at least 1 in this square means this square is 7, 8 or 9. And yeah, actually let's just stay on this arrow for a moment, because what you can't do is have 4 different digits on this arrow, because if they're all different, they would add up to at least 10. If I try 1, 2, 3 and 4 in there, that adds up to 10. So we can't do that, which means one of the cells on the arrow must repeat. Which one repeats? Well, we can't repeat any digits in box 6, so it's going to have to be that one. And if this repeats, and it must repeat, it can't repeat in those 2 cells because it's in the same column. So these 2 cells are the same digit, and that is interesting. And that digit cannot be too high. Yeah, no, it actually can't even be 4, can it? Because if I try 4 in those squares, the minimum this domino could be would be 1 and 2, and that would take us all the way to 11, which is definitely not equal to 7, 8 or 9. So these squares are 1, 2 and 3, I think. And we've got a start that involves colours and pencil marks. No digits, obviously, but that's quite exciting. Now let's have a look up here. We've got we've got useless arrows up here, haven't we? They look interesting because it looks like they're sort of spelling an X or something, but the problem is this square could be really low because this cell could repeat a digit in box 2. So if that's a 1 and that's a, that's perfectly possible. That would make that a 4, which is it's not really interesting. Oh no, hang on, sorry. This Ah, no, this arrow is the same as this arrow. I just didn't spot it. 1, 2, 3. Yeah, it's the same shape even. 1, 2, 3, 4. So this one we can just copy exactly what we've just done into these squares. So this square's got to be 7, 8, or oopsie, it's got to be 7, 8, or 9. This square and this square now must be, yeah, they must repeat, and they're not purple, so we can use a different colour for those. The reason they're not purple is that this is most certainly in the same row as that, so we can't repeat the digit. So already this is quite intriguing. Yeah, hang on. Now look. Now we can do, of all things, in a Sudoku video, Sudoku. Normally in Cracking the Cryptic videos, there is no Sudoku until a very late point in the video. But here, there's very early Sudoku, because where do you put green in box 1? It's going to have to be in one of those 3 squares. Now here's a knowledge bomb. Green can't be in this square because 1, 2, and 3 is not equal to 7, 8, or 9. Now green actually can't be there either because we just looked at this. This arrow, the minimum it could add up to would be 4 with 1, 2, and 1. So that's too low. So this must be green. And presumably that works the same way, and it does, over on this side. So purple goes with 1, 2, and 3. Now this looks very interesting. Now this looks very... Having condemned these arrows to being useless, I'm now wondering whether that was premature, because you can't put... So whatever green and purple turn out to be, one of those cells has to be higher than, has to be at least equal to 4. I suppose we can put it that way. One of these cells is at least equal to 4. And one of these cells is at least equal to 4. And the reason we can see that is we could make one of the digits low, but then the other digit obviously now can't be 1, 2, or 3, so it would have to be at least equal to 4. So, hang on. There's something about this that I'm finding... Whatever's in this square is not the same, and I know this is just stating the bleeding obvious, as Sybil Faulty or Basil Faulty may have complained to Sybil Faulty, but green and purple are not the same. But green and purple are also not the same here. Yeah, this is actually, I think, very interesting, because whatever the digit is, the low digit is, that I try and put into these squares, I think it has to be on the same arrow. I'm actually going to put digits in. Let's just imagine this was 1 and this was 3. Oh, whoopsie. Let's just do this. Now, if I try and put low digits into these yellow squares, where can I put them? The thing is, if I make that one a 2, I now can't put the 2 here. So it has to go on the same arrow. Which means that is absolutely beautiful. That is absolutely beautiful. Because it doesn't matter what we make these digits. We can, I can change these ones to being 2 and these ones to being 1. The point is that one of these arrows, and I don't know which one, but I know one of them has to have at least a 4 in 2 of its positions. That is absolutely stunning. I mean, we're doing more and more arrow Sudoku on the channel at the moment, and we keep finding these new ideas. Let's just double check this. So whatever I put in here, if I want to put it, on an arrow, I have to put it on the same arrow. Either that, or I have to go for a high digit. And if I go for a high digit, I'm just broken, aren't I? I mean, if I go for, if we just do this, let's just do this the other way. If we go for a low digit here, but decide these two are not going to be low digits for some reason, I mean, just to deal with it. If we go for 4 and 5 here, we don't want to put a 2 into these two squares. This still has to be high, and this still has to be 4, because otherwise this is just too high. So it's absolutely right, and it's absolutely beautiful to say, oh, oopsie, I've made a bit of a, I don't know what I've done there. I don't know what I've done. I'm going to have to replace the pencil marks, but they're not very difficult to replace. One of these arrows has to have double 4 on it. And I don't know which one, but what that does mean, whichever one of these arrows is double 4, what does it say about that square? That square has to be a 1, because we've got to make sure we don't make whichever arrow has double 4 on it breach the sort of upper barrier of 9. So one of these is a 9. One of these is a 9. I'm not sure what that means. I'm not even sure I know how to show that. I think I'm going to do that and just try and remember it. So one of these has got double 4 on it, but I don't know which one. But look, the 1 is looking at this 3-cell arrow. So this 3-cell arrow now has to be 2, 3, 4, or it breaks. So that gives me another digit. I've got a 9 here. Now, that might be useful. Yeah, look, 9 now in box 2 is restricted. This T pentomino can't have a 9 on it. You can't put 9 on an arrow, because that's going to make the circle have to be at least equal to 10, well, or 11 in this case, because it's a 3-cell arrow. So the 9 goes in one of those two squares in box 2, which means there's no 9 in those circles. So we get a 7, 8 pair here. We get that and that restricts all of these cells. You now can't have a repeated 3. If you've got a repeated 3 in the coloured cells, what do these squares have to be? Well, the minimum I can make them is 1 and 2. This would have to at least be 9. So we can just dispatch with this option. It just doesn't work. You can get rid of 3. You can get rid of 3 from there, which means you get rid of 3 from these cells. You've now got 1, 2 pairs all over the shop. This square can't be a 2. What else have we got? Have we got anything else? We might do. We've got... I'm not sure. I'm not actually sure I know what we've got now. But we do... So one of these is double 4. The other one now can't have 1 or 2 in either of its positions. Oh, this is beautiful. Again, this is beautiful. So, right, I'm just going to assume this one is the double 4. We don't know which way round it goes. But let's look at those two squares now and ask what these have to be. Now, what are the options? Well, we can put 3, 5, or higher. We won't need to go higher. We will break if we go higher. So, the minimum value for these squares is 3. Now we can't use a 3-5 pair because if we do, this will add up to 9, which is the same as what 4, 1 and 4 add up to on the other side. So 3-5 is not possible. If you put any digit higher than 5 with the 3, you obviously you'll add up to 10 or more. So the only way this can work is with double 3. So now we know, and we don't know which way round it goes still, but we now know that we've got 3s and 4s on this X shape. So let's actually pencil mark that in. So one of these is adding up to 9 and the other one is adding up to 7. So we've now got a 7-9 pair up here. We've got so we've got a 7 we just place in box 1 by Sudoku because 7's not in those squares and it's not on the arrow. We've got... Well, I've just noticed something else we've got, which is 7 is now restricted in this box. Because where does 7 go in box 5? You can't actually put 7 in these two squares now because that will shift 7 via the sort of medium of the arrow into one of those squares. Now if you get a 7 in either of these two positions, it will clash with the 7s. In fact, maybe I should go through why this is the case. This arrangement of 7s in boxes 1 and 3 is an X-wing, because if we think about if we look at the finished solution to this puzzle and we see there's a 7 in this square, then we know, because this will be an 8, we know this will be a 7 in box 3. So we know one possibility of the finished solution is that we have a 7 here and a 7 here in these yellow squares. Now, if, on the other hand, this is not 7, then we know that the 7 in row 1 must be there. Once this is 7, this is 8, and this is 7. So this would be the other possible arrangement of 7s in these two boxes. Now, the critical thing to appreciate about that is that there was always exactly one 7 in one of these two squares, and there was always exactly one 7 in one of those two squares. So there's no 7s anywhere else in these columns. So anything that puts 7s into these columns is illegal and we mustn't do it. So we can't have 7 in either of those squares. So 7 is in one of those two squares, which looks, as Mark would say, about as useful as a chocolate teapot, but it was exciting to do that. 1 as well, actually. Look, you can't put 1 in the arrows because 1 would shift into these two squares where we have a 1-2 pair in row 7 of the grid. So there is a 1-7 pair in the central box. There's a 9 in one of these two squares now. This is unbelievable. We've now got now there's an X-wing on 9s as well, because if you have a 9 in one of those, this is just superb. If there is a 9 in one of these two squares, we know one of those two squares is a 9 for certain. And we know one of these two squares is a 9 for certain. So we now know in the finished grid there's either a 9 in that configuration or there's 9s in that configuration. So we now know we can eliminate 9 from everywhere else in these columns. Now, so there's no 9 or 7 in this arrow. But it can still be actually very low, can't it? It could still be... I'm not actually sure it can't be 3 in this square with a 1-2 pair. There may be a reason that that's not possible. I just can't see what it is. 8 must be up there by Sudoku, using the fact there's definitely an 8 in one of those two positions. We can probably limit these two squares as a result of whatever goes in there. So if this is an 8, Actually, an easier way to look at that is just thinking about, we know these two squares are the same. If you get a 2 in both of these squares, this domino has to be something that will add this to 7, add up to 7 or 8. Well, if those add up to 4, the minimum I could make this domino would be a 1-3 pair, and that would add up to 8, and we couldn't put anything other than 1-3 in here because it would add up to too much. So 2 is always joined with 8, which means 7 by Sudoku must always be joined with 1, because obviously if we've got 2's in those squares, we know those two squares are 1, and we know that 2's go with 8, so this is an 8, so this will be a 7. So if it's 7, you get double 1. Yeah, okay. Actually, that is interesting, because let's just look at that. If that's 7, not only does it go with 1, but also these two squares now have to be a 2-3 pair. So whichever way round you do this with the 7 and the 8, these two squares are either a 2-3 pair or a 1-3 pair. So there's actually a 1-2-3 triple now in boxes 4 and 6, and we can't put 1 in those squares. And we've got a 3-4 pair here, which I didn't spot, interacts with the 2. So that limits these squares a bit more. There's no 2 here anymore. And so this square now can't be 1, 2, or 3. So this is at least 4. So this is at least 5. This square is at least 5 as well, because that sees 1, 2, 3, and 4 in its row. So this is at least 5. This is at least 5. Oh no, this one is the same. Right, now look at column 3 of the grid now, because there's more fireworks going on. We've now got this square has to be, well, you can see it can't be 1, 2, 3, or 4. So it's 5, 6, it can't be 7 by the X-wing, or 9. So it's 5, 6, or 8. This square, I haven't checked this one as carefully, but I can see it can't be. This square is at least a 4, so this is at least 5, because it's adding these two squares up. It's the same then. It's got to be 5, 6, or 8, because the 7 and the 9 are ruled out by the X-wing. Now this square, I thought could be a 3 or a 4, because I was looking at the row, but no, because it gets mirrored by the arrow into this square, where 3 and 4 is impossible. So this square also can't be 1, 2, 3, or 4, or 7, or 9. So that one, I think, is also 5, 6, or... Oh no, that one can be 9. Oh, I nearly made a mistake there. That can be 9, because, of course, 9 is one of the limbs of the X-wing, so that one can be 9. Otherwise, we'd have had a 5, 6, 8 triple. Well, it's still good. It's still good. We've got a quintuple now on 5, 6, 7, 8, and 9. And that square, so this square is a naked single because it can't be 1, 2, or 3. So that's a 4. Which means 4 is in one of the, 4 is in one of those two squares. These two squares are 1, 2, or 3. You can see that we've got a 1, 2 here, so the 3 must be down there. 3. Not sure. 4s. Got quite a lot of pencil markings in this puzzle at the moment. It's quite hard to keep track of them, especially as some of them don't mean quite what they normally do. These 9s, for example, I'm indicating an X-wing with those. Now, where do we look for more progress here? Now this, if this is 7, you get double 1, you get 2, 3. If it's 8, you get double 2. And you get 1. There's always a 3 in this domino. Sorry, I should have spotted that before. There's always a 3 in this domino. So 3s, 3s, 3s are up here. 3 is never in this square because there's a 3, 4 pair. There's a 3 in one of these two cells. Don't know. Must be a 3 in one of those two squares as well. So similarly up here there's a 3 in one of these two squares. 3 can't go in this square because it gets mirrored into a box where there's a 3, 4. So 3 is down here. That gives us a 3 in box 8 of the grid. We've got 3s aligning in these two, in box 7 and box 9. So there's no 3 in those squares. There's no 3 in those squares. We've got the 3, 4 pairs dealing with these two positions. So 3 can only go here and here. 4, not quite. 4. Oh, have I got the same? Yeah, hang on a minute. This is... So this arrow here is not mirrored on this side, whereas the almost all the other arrows are. These two are not symmetrical. That one is not symmetrical. I'm just wondering, this square, for example, can't be 1, 2, 3, or 4. So this one has our familiar restriction to 5, 6, or 8. Because 7 and 9 are ruled out by the X-wing. This one also, no, this one can be 4. Yeah, this one is not as restricted as that one was, but then this one takes its place. Yeah, okay, so this position here can't be 1, 2, 3, or 4. That has to be 5, 6, or 8. And this one can't be 1, 2, 3, can't be 4 because the 4 would get mirrored in here where it would clash. But this one can be 9. It's exactly the same as that one. So that one's 5, 6, 8, or 9, which gives us another of these quintuples, this time in column 7, which means we need 1, 2, 3, and 4. We know this square can't be 1, 2, and 3 because of the box. That's a 4. These squares are 1, 2, and 3. 4, oh no, I thought I was going to get the 4 up here, but no. Okay. So what happens next? What a remarkable puzzle this is. Thank you so much, by the way, to those people who suggested we do this. I really am appreciative of it because there are so many puzzles nowadays. Our testers are so busy, and it's tremendous boon if we get clear recommendations that say, look, this is a masterpiece, you just must do it. And when we get, in this case we've had 3, but if we get 2, 3, or 4 emails, then we're very confident to showcase the puzzles. I'm stuck. I've not looked at this arrow. So this arrow, this can't be 5 ever, because that will require this to be a 4 or less, and there's already 1, 2, 3, and 4 in the box. Sorry, that was easy. I should have got that before. Got it. Right. Okay. Let's think about this. The green. Can green be 2? That's the question to ask. If green is 2, we know it goes with 8 here, which means this is a 6. But now what on earth do you put in that square? You can't put 1, 2, 3, or 4 into the square, so it's absolutely broken, which is beautiful because that means that those squares are 1s, which means we know this is 7. it means we now know that's a 3 and that's a 2. We know this is an 8, these are 2s, this is a 3, this is a 1. And I'm sure this means a lot of very important things. We just have to figure out what those things are. Yeah, okay, 7, that unwinds the x-wings, look. So we get the 9s and the 7s here. But more important than that, well, as important as that, that means those are adding up to 3. These are double 3, these are double 4. But now the 9 here is removing a 9 from one of our x-wing squares. So we now know that the 9 must be in this position, and therefore this must be a 9. Now that fixes the 9 in box 2. Oh, what a puzzle. So now this square is no longer 9, but it still can be 5, 6 or 8. The square 5, 6 or 8 in the box. 5, 6, 8 triple in row 4. So those two squares are 7 or 9. Let's think about this now. Oh, sorry, 8s, look, by Sudoku. There's an 8 in one of those. There's an 8 in one of these two positions. 8 can't go there. That would be a 7, and that would clash. So the 8 goes here. So this row, we now need 5, 6, and 9. So this is a 5 or a 6, I think, only. We'll check this square in a moment. So 5, 6, and 9 in these squares. So this square has to be 4 or 5. Oh no, it can be either. Okay, that's probably not what we're meant to do next then. So, what are we meant to do next? We can... Everywhere I look, I seem to be seeing 5, 6s and 8s. I'm not sure what I'm meant to look at now. I mean, this arrow is obviously untouched in a way, but it's not... I don't think we know very much about it. 1 comes out of those squares. 2 comes out of these squares. Oh, that is useful. Sorry, look, I've got to fill in my 1s and 2s. Why don't I do the simple things? I know many of you will be really cross with me for that, but I am thinking about other things a lot of the time. I know you think that I'm just, I'm staring at things and not... But it's because I'm thinking about different things. So, what do we do next? We can... It's not actually... I'm not actually sure what... This arrow? 6 or 8. Yeah, hang on a moment. So there's a 5, 6 or an 8 here. 5, 6. Oh, that's gorgeous. Sorry, this is the way round we need to look at this. Look at the effect of this arrow combo on box 4. Whatever's in those squares is ruled out by Sudoku of all those squares, and 5, 6 and 8 are not equal to 7 and 9. So this square is a 5, 6 or an 8, and that's creating a triple in the box. Oh, this is going to be beautiful. It's going to disambiguate this arrow, isn't it? This is so clever. These two squares, yeah. So I'm actually going to highlight those so I can remember. Which colour shall I use? I'll use orange. So these are all the same. This square now by Sudoku has to be 7 or 9. So you can see there's no way we can make this 6 anymore. This is going to have to be 8. This is going to have to be 7. This is going to have to be 9. That's going to have to be 7. These two squares can no longer be 8, which means these two squares can no longer be 8. 8 is not here. That gives us a 5, 6 pair in this row, and it places the 9 in box 6. That's not a 9 anymore. That means this square's a 9. Mind-blowing, this puzzle. 5, 6 or 8 into this square. So we now see there's an 8 in in this domino. In fact we know where it goes apparently. Yeah, this square's an 8 by Sudoku. This square's an 8 by Sudoku. Maybe I'm not saying anything actually about maybe we're closing in on anything. We're not closing in on anything. Ignore that comment. See, this can still be 4 or 5 apparently. If I could, yeah, so there's, but whatever, there's something going on with 5s and 6s here. Because this 5 and 6 is obviously not the same as this 5 and 6. I'm going to colour it differently. Because that's also a blue 5 or 6. Now that means this is an orange 5 or 6. These are blue 5s and 6s. By Sudoku, look, this square is not 8. It is an orange 5 or 6. Which means, oh, look, yeah, that's gorgeous. So that means that the 5s and 6s, whatever this is, by Sudoku, gets shunted into that square, and therefore it can't be a 6, it's a 5. Oh, that is lovely. 5, 5, 5, 5, 5, 6, 6, 6, 6. I'm going to make that orange because it deserves it. This square is an orange 5. There's a 5 down here. So we'll make that a 5, 8 pair. So these two squares up here are 4 and 6. Oh, it doesn't resolve. These two squares are 1 and 3. That must resolve. Yeah, it does. 1 and 3. So can we keep going with the... Maybe we can keep going with the 5s and the 6s. I'm not sure actually. 3 here is forcing the 3 up there. So we still need to place 2 and 4, which we can do in box 1. 2 and 4 go in. That fixes the 4 and the 6 over there. That gives us a 6 here, which I should make blue. These two squares are a 2, 8 pair, which doesn't seem to be resolved. But hopefully now, I think we ought to have some joy down on the, you know, in places like this. We should be able to get a 6, 7 pair there, which means those squares are 4, 8 and 9. At least the Sudoku side seems to be working. 9 goes in here. It's going to be this arrow, I suspect, that disambiguates the last piece. These squares are 4, 6 and 7. So this is not 4. Okay. So what can this digit be? We've got to keep this down a little bit, don't we? Is there an easy way of seeing what this is? I can see it can't be 3 or 4. I can't really see 1 or 2 being a problem. I mean, actually 1 or 2 can be ruled out because we never get to 6 or 7. There's an easy win. So it must be at least 5, and it can't be 6. So it is 5. Sorry, that was much easier than I was expecting. 3, 4, 1, 2. Yeah, okay, so it is 5, which means this is 1, which means this is 6. The 5 and the 8 get resolved. The 8 and the 4 get resolved. Please keep going. 4 and the 7 get resolved. 7 and the 6 get resolved. The 3 and the 2 get resolved. This should be a 2. That fixes the 2 and the 8. That fixes the 8 here. We still need a 1. We need a 1, a 7, We need a 7 and a 6. And that is as good a Sudoku puzzle as you will ever see. As you will ever see. Elias Kar, what a debut on this channel. I loved that. That is just mesmeric. Let me know in the comments how you got on. I really hope you gave the puzzle a try, and I really hope you finished it, because I think it will have given you an awful lot of joy. Thanks so much for watching. I will be back later with another edition of Cracking the Cryptic. And I know actually you're going to be cross with me if I don't highlight all the 6s in blue and all the 5s in orange. So let me do that now. Why won't you let me do it, machine? 5s. 1, 2, 3, 4, 5, 6. Yeah, I think that's all the 5s, isn't it? I'm not doing all the greens because the greens and the purples were for different purposes. There we go. See you later on Cracking the Cryptic.